Well, hi there, and welcome to part six, the final section of our discussion of the wild world of volcanoes. In this section, we're going to talk about the mitigation and prediction of volcanic hazards. In other words, what can we do about these volcanic eruptions? Run for your life? Well, actually, you cannot even do that because uh, you typically may have no time to do it. Before I go into details here, let me tell you the on the picture. I remember the day they took this picture. The wind was really blowing, and I'm standing with the volcanic deposits of Waimea Canyon in the background. This is in the island of Kauai, uh, on the island, the Hawaiian island chain. If you ever get a chance to go there, this is a cool, neat place. Okay, what do we do in terms of the prediction and mitigation of volcanic hazards? Uh, the first thing we need to do is try to attempt to estimate how large of an eruption we're going to have. And in order to do that, we have to determine or predict the volcanic explosivity index and the effects of the eruption. Typically, we start by trying to reconstruct the volcano's eruptive history. We should determine the type and origin of the volcanic deposits and date them using radioactive dating techniques in order to determine the actual chronology and the frequency of past eruptions. Now, fortunately, these volcanic rocks tend to have enough radioactive isotopes that we can use these as clocks to uh, put an actual age on these rocks. We also have to accurately map these volcanic deposits to predict the future aerial extent of the potentially affected areas. And we must aggressively monitor active volcanic cones. One technique that we can use to try to predict an imminent eruption is by trying to monitor seismic activity in the vicinity of a volcanic cone. Volcanic seismic activity can include short period earthquakes, long period earthquakes, and harmonic tremors. Short period earthquakes are caused by the fracturing of brittle rock as the magma moves upward. In contrast, long period earthquakes are caused by an increase in gas pressures uh, in the volcanic magma chamber. And harmonic tremors are a sustained release of seismic energy resulting from the magma pushing against the overlying rocks or the overlying strata. We can surmise then that an increase in the long period earthquakes and the harmonic tremors in the vicinity of a volcano could spell bad news in terms of an imminent volcanic eruption. Another way in which we can try to predict an upcoming eruption is by monitoring gas emissions in the vicinity of volcanic cones. As magma rises, pressure decreases and gases tend to escape from the magma chamber. Uh, Therefore, rising concentrations of sulfur dioxide detected at the surface may signal the upward movement of magma. Uh, Interestingly enough, in some cases, drops in the sulfur dioxide concentration might point to the plugging of gas passages by hardened magma, leading to increasing pressures in the magma chamber and the enhanced potential of a really nasty, violent, explosive eruption. Detecting changes also in the carbon dioxide to sulfur dioxide ratio uh, caused by degassing of rising magma uh, can also be a tool that we can use to try to predict an imminent eruption. In the picture here, you can see some steam and sulfur gases escaping at sulfur springs in St. Lucia. Other techniques to try to predict an imminent eruption is by monitoring thermal emissions as well as ground deformation. Changes in thermal emission values in the vicinity of a volcanic cone may indicate potential eruptions. Now, how do we monitor these? Well, we use essentially three techniques. The forward-looking infrared radiometry, the infrared band satellite imagery, and the in situ thermometry at hot springs and fumaroles. Also, ground swelling and slope tilting, especially coupled with rising values of sulfur dioxides and harmonic tremors, can be indicators of an imminent eruption. The picture here, I'm standing with Le Petit Piton in the background. Remember, this is in the island of St. Lucia in the Eastern Caribbean. Go there, you get a chance. This is a cool place. Other techniques in trying to predict volcanic eruptions include hydrological indicators and mass movement indicators. For example, rising water levels can occur in wells due to the increasing gas pressures from a rising magma. Debris flows and lahars can occur before, during, and after a volcanic eruption. Also, monitoring nearby stream channels may prove very helpful through the detection of increasing volumes of pre-eruption sediments or changes in the morphological attributes of a stream channel, such as the width of the channel and the depth of the channel. Picture is an outstanding area, the Waimea Canyon again, and the volcanic strata that you find in the island of Kauai in Hawaii. This is the so-called Grand Canyon of the Pacific, as I mentioned before. You get a chance, go there. Last but not least, we can use remote sensing techniques to try to predict the imminent risk of a volcanic eruption. Electromagnetic energy that may be reflected, radiated, absorbed, or scattered from the surface of a volcano is detectable via satellite sensors through remote sensing techniques. Water droplets and water vapor and ice particles preferentially absorb infrared at longer wavelength than volcanic ash. Therefore, we can use remote sensing techniques to try to differentiate between the unusually cold volcanic eruption clouds and the common clouds, the meteorological type clouds. Also, changes in thermal and gas emissions as well as ground deformation may be substantiated using remote sensing techniques. Picture here, another victim from the terrible eruption of Mount Vesuvius that destroyed Pompeii. This one is particularly heartbreaking because you have a pregnant woman that was buried alive in this ash and suffocated from this ashfall. Well, guess what? We have reached the end of our topic, the wild world of volcanoes. My hope is that you have found the material interesting and that I have given you some information that would be of value to you. I'm passionate about this subject. I'm hoping that you also will be. Thank you and good luck.